Good morning, students. Today we will start understanding Coulomb's law. The basis of electrostatics is Coulomb's law, most important. All the other structures, whatever we build in electrostatics, it is with the foundation of Coulomb's law. Therefore, it is a very significant, important law based on the observations of Coulomb's law. We will be able to build the other parts of the cell. Very easy. Carefully observe. Coulomb's law basically speaks about the force between two charges. See, I am considering two charges separated by some distance. Two charges which have been separated by some distance d. According to Coulomb's observation, he has found that between two charges, suppose if you assume that these two are positive charges, they repel each other. If you assume that one is positive, other is negative, they attract each other. If both are negative, then also they repel each other. Therefore, in between the two charges, based on the nature, we can either have force of attraction or force of repulsion. This magnitude of this force is there in between. How much force is there? If you want to measure that, Coulomb gives an observation. He says, according to Coulomb's law, force is directly proportional to the product of charges, and the same force is inversely proportional to square on the distance of separation. Must understand? It is based on the torsion pendulum experiment, what was done by him. Based on that experiment, he was able to come to a conclusion that force is directly proportional to product of charges and force is inversely proportional to square on the distance of separation. So combining the two, one can write that force is directly proportional to Q1 Q2 divided by d square. Later, he observed one more thing. See, between 2 point charges there is some force. When you introduce a material medium in between, people started finding a variation in the force. Between two charges, Coulomb found that force of either attraction or repulsion is maximum only in vacuum. You go to any other medium, force always reduces. Therefore, he found that there is a direct influence of the medium on the magnitude of the force. So, by doing suitable calculations and theoretical arguments, he was able to show that the constant of proportionality, if I want to remove proportionality sign here, I must introduce some constant and equality. So 4 pi epsilon naught Q1 Q2 divided by d square. Here this epsilon naught is called permittivity of the medium. Permittivity of the free space. Permittivity of the free space. So this is for free space, means vacuum, where there is nothing. If you go to any other medium, this constant will change. So 1 by 4 pi epsilon naught is the constant that is decided by the medium what comes in between the 2 point charges. There the epsilon naught is a constant called permittivity of free space. Suppose if you go to some other medium, there for any other medium, try to understand this, for any other medium, how do we write the expression? It is like this. F is equal to 1 by 4 pi epsilon naught Q1 Q2 by d square. We were writing it for vacuum. Here we just write epsilon. So if you write epsilon, it is for any other medium. So if you write epsilon naught, it is for free space. Its value therefore depends on the medium. Constant epsilon permittivity changes from one medium to the other medium. Always this force will be something different from this force. Most important, force in any medium is always less than force in air or vacuum. So force in any medium is always less than force in vacuum. Maximum force between two charges you will be able to notice only in vacuum. Important. Okay. Therefore, you can understand one fact here. Forces varying inversely with the permittivity. So, for a particular medium, if the permittivity is large, then force is always small. If permittivity is small, then force is large. ಈಗ vacuum ಅಲ್ಲಿ maximum force ಇದೆ ಅಂದ್ರೆ vacuum ಅಲ್ಲಿ smallest permittivity ಇದೆ. So permittivity of a medium is very small. In which case? It is in case of vacuum. You must remember. Therefore, ultimately, the mathematical form of Coulomb's law is this: F is equal to 1 by 4 pi epsilon naught Q1 Q2 by d square. The simplest mathematical form for the magnitude of the force is F is equal to 1 by 4 pi epsilon naught Q1 Q2 by, it should have been d square. Let me correct it, d square. Okay. So this is the mathematical form of Coulomb's law. I think you have followed all this. Now let me tell you the value of epsilon naught. In case of air or vacuum, for air or vacuum, epsilon naught value is equal to 8.854 into 10 to the power of minus 12 SI units. How do we write the SI unit for epsilon naught? I will tell you later. At the moment, you just remember its value in SI system is 8.854 into 10 power minus 12. This is the permittivity of free space. You go to any other medium, its value keeps changing. Okay. Now, we will understand few more important facts about Coulomb's law. The first case of writing the Coulomb's law in its vector form. What is that case one? I write like this. Try to understand. I am writing Q1 Q2 product is greater than 0. Must understand. See, product of two numbers will be greater than 0 if and only if both the numbers are positives or both the numbers are negatives. ಅಂದ್ರೆ ಇದು ಪಾಸಿಟಿವ್ ಇದ್ರೆ ಮಾತ್ರ ಪ್ರಾಡಕ್ಟ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ 0 ಗಿಂತ. ಇದು ಪಾಸಿಟಿವ್ ಇದು ನೆಗೆಟಿವ್ ಇದ್ರೂ ಪ್ರಾಡಕ್ಟ್ will be greater than 0. Therefore we must understand Q1 Q2 is greater than 0 only when ಯಾವಾಗ ಹೇಳಬೇಕು? The charges considered are like charges. So ಹೀಗೆ ಬರೆದ್ರೆ you must understand that two are like charges. In between like charges, what kind of force do you feel? It is repulsion. Repulsion ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ? Q1 will repel Q2 in this direction and Q2 will repel Q1 in this direction. Okay. So force on 2 due to 1. Try to understand the subscript. I am writing force on 2 due to the charge 1 vectorially acts in this direction. Similarly, how do I write here? Force on 1, force on first charge due to second charge acts in this direction. These two forces are repulsive forces acting in opposite directions. How do we write the expression for this? Let's understand it. F21 I want. F21 vectorially is 1 by 4 pi epsilon naught. Try to understand. F21 vectorially is 1 by 4 pi epsilon naught product of charges divided by distance square. See, since the force is acting along the line joining two charges either that way or this way, on that line I select a unit vector and multiply this by that. Now again D12 cap. I consider a unit vector D12 cap. When you multiply the magnitude by a unit vector, you get its vector form. Therefore, 1 by 4 pi epsilon naught Q1 Q2 by d square is the magnitude and D12 cap shows you the direction. In what direction it is? D12. From 1 to 2. In this direction the force is acting. This is case 1. This is case 1. Even you can write the subscript here, no problem. Anyway, this is magnitude. Whether we write it or not, D12 or D21 in magnitude remains the same. Now let me consider the second case. See, the same two charges I am considering. Q1 is one charge, Q2 is another charge. They have been separated by a distance d. Now let's say one is positive, other is negative. How do I express that? I write that as case 2. Case 2. In case 2 I write Q1 Q2 product is less than 0. What does it mean? Q1 Q2 product is less than 0 means product is less than 0 andre negative number. Product of two numbers will be negative only when one of them is negative. Therefore here one must be positive, other must be negative. So this is the way we describe unlike charges. This is the way we describe unlike charges. You must understand. This is how we describe unlike charges. So Q1 may be positive, Q2 may be negative, or Q2 positive, Q1 negative. In that case what happens? They attract each other. One will exert force on 2 which is attractive. So force on 2 due to 1 will be acting this way. Similarly, force on 1 due to 2 will also be acting in the same direction. This is F12. Vectorially, these two are now attractive. How to write the expression? Very simple, carefully observe. Now I want F21, let's say. F21 vector is equal to 1 by 4 pi epsilon naught. Same magnitude, Q1 Q2 by d square, no change. But direction yav kade ide? 2, F21, the force experienced by 2 due to 1 is now directed from 2 to 1. 1 to 2 illa force. Here it was from 1 to 2. Here it was from 1 to 2. But here it is from 2 to 1. Therefore here I write D21 cap. D21 square, D21 cap. Did you understand? Like the same you can write the other expressions. If you want F12 here, F12 is equal to 1 by 4 pi epsilon naught Q1 Q2 by D21 square and D21 cap. Here if I want to write the F12, how do I do that? F12 is 1 by 4 pi epsilon naught Q1 Q2 by D12 square D12 cap. Okay. F21 is from 2 to 1. Therefore D21 I have written. But this is from 1 to 2. That's why I have written 1 2. I think you are understanding this. Okay. So this is all about the vector form of the Coulomb's law. Try to understand how do we read this subscript? Force on 2 due to 1. Force on 2 due to 1 is directed from 1 to 2. Is directed from 1 to 2. Force on 2 due to 1 in this case. Force on 2 due to 1 is directed from 2 to 1. Therefore I am writing D21 cap. Okay. You have followed the Coulomb's law in vector form. Now the second understanding about Coulomb's law we will follow very easy. Carefully. F21 vector was what? 1 by 4 pi epsilon naught Q1 Q2 by D21 square D21 cap. We got right? Ade branch alli F12 game bandittu. It was 1 by 4 pi epsilon naught Q1 Q2 by D12 square D12 cap. Now if you look at these two, you can understand one thing. Exactly the two are same in magnitude. Magnitudes are identical. Only directions are changing. Therefore, F12 vector in magnitude will be exactly equal to F21 vector. Okay. But F12 vector in direction as opposite to F21 vector. So you must remember, forces are equal in magnitude but opposite in direction. That is the reason why these forces are called Newtonian forces. Because they always exist in pairs. They are equal and opposite. Okay? Therefore, these are called Newtonian forces. See, there one question carefully. There is one 10 coulomb charge and there is another 2 coulomb charge. In between the two, the distance is d. One question ಕೇಳಬಹುದು ಏನಂದ್ರೆ ಈಗ ಎರಡು ಚಾರ್ಜ್ ಮಧ್ಯೆ ಡಿಸ್ಟೆನ್ಸ್ ಎಷ್ಟೋ ಕೊಟ್ಟಿದ್ದಾರೆ, ಮೇಬಿ 5 ಸೆಂಟಿಮೀಟರ್ ಲೆಟ್ ಅಸ್ ಸೇ. Whether 10 coulomb exerts more force on 2 coulomb or 2 coulomb exerts more force on 10 coulomb, ಯಾವುದು ಜಾಸ್ತಿ ಫೋರ್ಸ್ ಇರುತ್ತೆ? Try to understand. Force individual charge ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಲ್ಲ. Force depends always on the product. Therefore, whatever the force 10 coulomb is experiencing due to 2 coulomb, ಅದೇನು ಅಂತ ಬರೋ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಬರಿ ಅಂದ್ರೆ F is equal to 1 by 4 pi epsilon naught 10 into 2 divided by distance square. ಅದೇ ಇದಕ್ಕೆ ಫೋರ್ಸ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಬರಿ ಅಂದ್ರೆ ಆ ಫೋರ್ಸ್ को 1 by 4 pi epsilon naught 2 into 10 divided by distance square. So this is A beam. This is force experienced by A. This is force experienced by B. If you observe, their magnitudes are same. ಹಾಗಾಗಿ ಎರಡು ಚಾರ್ಜ್ ಇದ್ದಾಗ irrespective of their magnitudes, both of them will exert and experience same force. You must understand. ಎರಡು ಚಾರ್ಜ್ ಇದ್ರೆ ದೊಡ್ಡದಿರಬಹುದು ಚಿಕ್ಕದಿರಬಹುದು. ದೊಡ್ಡದು ಚಿಕ್ಕದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಏನು ಫೋರ್ಸ್ ಹಾಕಲ್ಲ, ಚಿಕ್ಕದು ದೊಡ್ಡದಕ್ಕಿಂತ ಕಮ್ಮಿ ಏನು ಫೋರ್ಸ್ ಹಾಕಲ್ಲ. Force always depends on the product. Always depends on the product, you must remember. So force exerted and experienced by A is same as that done by B. ಗೊತ್ತಾಯ್ತಾ? Important point ಜ್ಞಾಪಕ ಇಟ್ಕೋಬೇಕು. Okay? Important applications have been mentioned in our syllabus. We must follow it. First one is to define relative permittivity. Relative permittivity. Remember, epsilon is the symbol for permittivity. How do I pronounce this? Epsilon for permittivity. If I write epsilon R, what does it mean? Relative permittivity. Let's understand how to define it. Now let me consider two charges. Q1 as one charge and Q2 as another charge. Q2 as another charge. They have been separated by a distance d. They have been separated by a distance d. Q1 and Q2 are the two charges separated by a distance d. Now the force that is existing in between in air or vacuum is 1 by 4 pi epsilon naught Q1 Q2 by d square. Okay. Now I consider the same two charges. Q1 and Q2 are the same two charges which have been separated by the same distance, but it is in a different other medium. I mark like this. Ignore. Here it is not air or vacuum. Some other medium is there in between. The two charges have been separated by the same distance, but there is a medium existing. This is in air or vacuum, but this is in some medium. Here, how do I write the expression for force? Force is equal to 1 by 4 pi epsilon naught Q1 Q2 by d square. Q1 Q2 by d square. But in addition to that, here I multiply it by another term called relative permittivity. Q1 Q2 by d square. Earlier I told you that in vacuum we write epsilon naught. In any other medium we simply write epsilon. But the same epsilon is here expressed as epsilon naught into epsilon r, where epsilon r is called relative permittivity. Epsilon r is called relative permittivity. This is in a medium. This is in a medium. This is in air. Now to define relative permittivity, I take the ratio of the two. This is equation 1. This is equation 2. Take the ratio of 2. Andre 1 divided by 2. 1 divided by 2 if you do, it is force in air by force in any medium. Force in air by force in any medium will be equal to. Now to divide madidre enagutte? Force in air is 1 by 4 pi epsilon naught q1 q2 by d square. Force in any medium is 1 by 4 pi epsilon naught epsilon r q1 q2 by d square. 1 by 4 pi epsilon naught goes with 1 by 4 pi epsilon naught. q1 q2 by d square, q1 q2 by d square. Ultimately, you are left with epsilon r in the numerator. Therefore, how to define relative permittivity? Very simple. Relative permittivity epsilon r is equal to force in air by force in a medium between any two specific. Relative permittivity epsilon r is the ratio between two charges separated by a certain distance in air or vacuum to the force between the same two charges separated by same distance in a given medium. Try to understand. Relative permittivity is the ratio of force between any two charges separated by a certain distance in air or vacuum to the force between same two charges separated by same distance in a given medium. If you take the ratio of that, you will get relative permittivity. Must remember, relative permittivity has no unit. Observe carefully. Melgadeno force Newton, Kelgadeno Newton. Therefore, there is no unit for this. Therefore, epsilon r is a unitless, dimensionless number. Dimensionless number. You must understand. It has got no unit, no dimension. But remember one thing. Force in vacuum is always greater than force in any medium. Therefore, this is always a number greater than 1. Relative permittivity is always a number greater than 1. But in case of conductors, but for metals, that means conductors, epsilon r is equal to infinity. Relative permittivity is infinite, very large value for metals. If you separate two charges in a metal, there is always a chance of the two being conducted by that. Then there is no meaning for the force. The force in the medium, if it drops to 0, something by 0 becomes infinity. Relative permittivity will be infinity. Relative permittivity will be infinity. In metals between two charges, force may not exist like what you have in vacuum or air or any other direct medium or any bad conducting medium. Therefore, relative permittivity for metals is infinite. Must remember. It is greater than 1 for any medium, infinite for metals. For air or vacuum, if you calculate this, for air or vacuum, try to understand. For air or vacuum, epsilon r ಏನಾಗುತ್ತೆ ಮೇಲ್ಗಡೆನೂ air ಅಲ್ಲಿ second medium air ತಗೊಂಡ್ರೆ this will be equal to 1. Relative permittivity is a number equal to 1 or greater than 1. Equal to 1 for air or vacuum, free space, and greater than 1 for any medium, and it is infinite for metals. Okay, I think you have understood this. For charge, remember, between two charges q1 and q2, between two charges q1 and q2 separated by a certain distance, force existing is given by 1 by 4 pi epsilon naught q1 q2 by d square in air or vacuum. I told you that this constant epsilon naught is 8.854 10 power minus 12 SI units. Therefore, I can write force as equal to, if I substitute epsilon naught, pi value and 4 here, I get this ratio as nearly equal to 9 into 10 to the power of 9. Must remember, 1 by 4 pi epsilon naught is nearly 9 into 10 to the power of 9 into Q1 Q2 divided by d square, where you try to follow 1 by 4 pi epsilon naught has been written as 9 into 10 to the power of 9. Okay. After having this, let me impose a condition. Under the circumstance when Q1 is equal to Q2 is equal to 1 coulomb. Coulomb is the SI unit. If I assume that these two are 1 coulomb and the distance of separation is equal to 1 meter, then force becomes equal to 9 into 10 to the power of 9 newtons. Isn't it? 9 into 10 to the power of 9 newtons. Therefore, I can say like this. Try to understand. Q1, Q2, 1 coulomb agi 1 meter distance allittaga ishtu force barutte. Suppose you have unknown charge unknown identical charges. Adana air or vacuum 1 meter ದೂರದಲ್ಲಿ ಇಟ್ಟಾಗ ಇಷ್ಟೇ ಫೋರ್ಸ್ ಏನಾದರೂ ಬಂದ್ರೆ ಅದೆರಡು ಒಂದೊಂದು ಕೂಲಮ್ಮೆ ಆಗಿರಬೇಕು ಅಲ್ವಾ? ಟ್ರೈ ಟು ಫಾಲೋ. Q1 Q2 1 ಕೂಲಮ್ ಆಗಿ ಡಿಸ್ಟೆನ್ಸ್ 1 ಮೀಟರ್ ಇದ್ರೆ ಇಷ್ಟು ಫೋರ್ಸ್ ಬರುತ್ತೆ. ಇಷ್ಟು ಫೋರ್ಸ್ ಬಂದಿದೆ, ಯಾವುದೋ ಐಡೆಂಟಿಕಲ್ ಚಾರ್ಜ್ 1 ಮೀಟರ್ ದೂರದಲ್ಲಿ ಇದ್ದಾಗ ಇಷ್ಟು ಫೋರ್ಸ್ ಬಂದಿದೆ ಅಂದ್ರೆ ಅದೆರಡು ಒಂದೊಂದು ಕೂಲಮ್ ಆಗಿರಲೇಬೇಕು. Therefore 1 coulomb is that charge. Try to understand. 1 coulomb is that charge which when separated by another identical charge in air or vacuum by a distance of 1 meter exerts and experience a repulsion of 9 into 10 to the power of 9 Newton. You must understand. If two identical charges separated by a distance of 1 meter in air or vacuum experience and exert a force of 9 into 10 to the power of 9 Newton, then essentially the magnitudes of either of the charge must be equal to 1 coulomb. This is the important fact. Okay, based on Coulomb's law, define the SI unit of charge. Maybe a question in the exam, very important, you must answer it this way. Okay, superposition of forces, must understand. Try to follow. I consider a charge Q placed somewhere here. Say this is Q1 and there is another charge Q2. Q1 and Q2 are the two charges which have been separated by some distance, say d. Now in between the two, force is existing. Now one ಕೆಲಸ ಮಾಡ್ತೀನಿ. I'll fix this charge to its position. Move ಆಗಲ್ಲ. ಇದು ಮಾತ್ರ it experiences force and it may move. Let's say ಇದ್ರ ಮೇಲೂ force ಇದೆ, but since I have fixed this charge, even though the force is existing, it may not move. But the other charge which is free to move may experience the force and execute the motion. Let us say this is the force on 2 due to first charge. Suppose if there comes a third charge. Try to understand. If there comes a third charge will exert a new force in this direction, but the already existing force is not disturbed. Adithe irutte, adra jotege idu innonu barutte. Okay, so the principle of superposition of forces, you must understand that if there is a force between two charges, that force is not disturbed by the presence of a third charge. Third charge will simply introduce a new force. Okay, now the net force on the charge 2 will be in this direction. This is called resultant force. Say I call that as F3, resultant of the two forces. Now in presence of this, if I introduce one more charge, Q4, in presence of all these three charges, I am bringing one more charge. Q4 will exert a repulsion in this direction. I am calling this as F4. Now, due to the two other charges, there was a resultant F3. Now, in addition to that, one more force has come. Now, you must calculate the resultant by considering these two, F3 and F4. Maybe this is the resultant of the three forces, ultimate resultant of three forces. I call this as F5. Like this, by making use of principle of superposition, it is possible to find out the total force on a charge. Adharanne hege helbodu, total net force on any charge in the system of charges is always equal to the vector sum of all the individual forces acting on that charge. Remember, the force between two charges will never be disturbed or reduced or increased by the presence of a third charge. Third charge can only introduce a new force. It may alter the resultant, but existing forces are always the same. That is not disturbed. Okay, this is about principle of superposition of forces. I think you have followed. While solving most of the problems, we go for this method. While solving most of the problems, we go for this method, a very important method. Okay. Next point is about writing the units and dimensions for different physical quantities, whatever we have observed so far. First of all, we started with charge. Remember, in SI system, charge is not a fundamental quantity. Charge is not a fundamental quantity, but electric current is a fundamental quantity. How do I write electric current? Electric current is charge divided by time. Therefore, charge is equal to current into time. So, principal unit of charge, principal unit of charge must be ampere second. Ampere second, current into time. But that ampere second is itself called coulomb. Ampere second is itself called coulomb. We have already understood the definition of coulomb. Now to write the dimension for the charge, dimension of charge is equal to dimension of current into dimension of time. Dimension of current is ampere, dimension of time is t, therefore it must be essentially AT. So dimension of charge is always equal to AT. Okay? The unit and dimension of charge we have followed. See, now the electrostatic force we are considering. Whatever it is, force is a physical quantity, whether it is electrostatic force, mechanical force, whatever it is, gravitational force, unit and dimension remains the same. Therefore, for force, the unit will be here also Newton unit. And dimensional formula that force is same, ml t minus 2. Dimension ml t minus 2. First year and force unit is Newton. Next, permittivity ನೋಡಬೇಕು. ನಾನು ಆಗಲೇ ಹೇಳಿದೆ SI unit ಅನ್ನು ಬರೆದಿದ್ದು, ಯೂನಿಟ್ ಬರೆದಿರಲಿಲ್ಲ. ನಾವು equal to 1 by 4 pi epsilon naught q1 q2 by d square. If I solve for epsilon naught would be 1 by 4 pi f q1 q2 divided by d square. Correct? 1 by 4 pi f q1 q2 by d square. Now I want to write the unit for this. Unit of epsilon naught I want. Yen baritini 1 by 4 pi constants. They have no specific unit. q1 q2 charge coulomb square by force Newton, distance square, meter square. Therefore, you can write the unit like coulomb square per Newton per meter square. Coulomb square per Newton per meter square is the unit of epsilon naught. Similarly, if you want to write the dimension for this, dimension of epsilon naught is something like coulomb is 80 square by Newton mlt minus 2 meter square L square. On simplifying this, you get a square t square m minus 1 L minus 1 t plus 2 L minus 2. you just simplify this. M minus 1, mass term one day one. L square, L cube, when comes to numerator it should become L power minus 3. L power minus 3. T square, T minus 2. T square, T power 4. A square. This is the dimensional formula for relative permittivity. Note ko hand badidu. Coulomb ge AT, dimensional formula. So Coulomb square, AT square. By Newton, MLT minus 2. Meter square, L square. Therefore it is A square, T square. M comes to numerator M minus 1. L minus 1. T minus 2 comes to numerator T plus 2. L minus 2 it becomes. Therefore finally you end up with this. M minus 1, L minus 3, T4 and A square. That is the dimensional formula for permittivity. Okay. So these are the things that you need to follow in the unit called electric charges. Okay. So by now we have finished electric charges. In our next class we will move on to the next topic, electric field. That is a bit more complex compared to this. There are so many derivations to do. All the derivations you must follow properly. Slowly we will do, no problem. Again, carefully observe and try to understand everything. Hope you are all following. Have a nice day. Don't leave the studies. Let there be continued studies. Properly follow everything. If you have any doubt, you please let us know. Okay? You please call us and say your doubt. It will be clarified in the next class. Okay? Thank you.